Okay, so what I'm going to talk about is the real purpose of Bitcoin, which isn't all the Google stuff, which isn't anonymity or any of this other sort of BS out there. It isn't money that governments can't get or any of the mythologies. People have forgotten the past. Some of you are too young to remember it because during the period of the late 80s to early 90s and right up to about 2001, there were over 1,000 cryptocurrencies. Bcash, Sean lost out on the deal with Microsoft because he wanted 1/3 of Microsoft, all the rights to use it, which Bill Gates laughed at. And after that, everything crashed. But the whole point was, it wasn't that they're the first decentralized cryptocurrency. That was actually 93. It wasn't the first of any of these things. The only thing that Bitcoin offers that is completely new is the first traceable system. The first one that has an immutable ledger that means no matter what you do, there's always a record. It's private, it's not anonymous. So, Bitcoin is a peer-to-peer system. This does not mean the network the way people think. The network is not peer-to-peer. The people are peer-to-peer. So peer-to-peer networking means I give something to someone else. And when I first released Bitcoin, it included IP-to-IP transactions, and it was even based on IPv6. Because if you're going to have peer-to-peer connectivity, doing it through NAC doesn't work. So you need something where people can actually connect to each other. Now, connecting to each other is an important part of how the system is meant to work. It is, I connect to the other person. I give my transaction to them. I don't go out there in a non-scalable manner and send it to a small network of miners that have growing concerns and then have someone search through those trying to find my transaction. And this is an important aspect. If you think about it, that limits the ability to any scaling. If you have to go and search for your payment, then the bigger the block of transactions happens to be, the more you have to search through. And it's effectively a knapsack problem. So if we have a multi-weight, multi-variable knapsack problem, there's no easy solution. We can't even do a reduction into something that works. So how do we solve that? We don't search the knapsack. We just simply go out there and I hand you the transaction. If I connect it directly to you, then there is no knapsack problem. There is no having to actually search for the transaction. So privacy is also enhanced this way. If I'm talking to you, that's private. Now the argument, of course, is, oh, but people know each other. Yes, in normal transactions that don't involve child porn and illicit things like this, people know each other. If I want to buy a television from Amazon, I don't go out there with a pseudonym and have maybe in the middle of the park on 11 a.m. at night, go, yes, drop the television on the third park bench on the left. I'll be there in a trench coat wearing a white hat. I mean, really, is that how people normally trade? I actually like, when I buy things, to know that I can get a warranty. When it doesn't work, I can go back and do things and get a replacement. So anonymity is not there to actually protect anyone other than the drug dealer. If you think about it, even with Silk Road, the people who were in trouble were the people buying. You don't know who the drug dealer is, but hey, it's okay. I'll give him my name, address, and everything else so that he can deliver my drugs. That always works out really well. So, Bitcoin is about pure IP-to-IP connectivity. This is how it scales, and this is how all these other things work. The way that it is, Alice hands the transaction to Bob. Bob has it registered and settled on the network so that no one can double spend. Alice and Bob are the people who need to care. Charlie down the road there doesn't care. All this, we need to validate everyone's transactions. No, we don't. If Alice and Bob don't deal with Charlie, Charlie doesn't care about Alice and Bob. Why does Charlie need to sit there and go, oh, look, Alice and Bob are being transacting? The IP-to-IP connectivity is the heart of this. And if we're going to make this work, then we need direct, basically person to person, IP to IP, machine to machine connectivity. Now, there's one way we can do that. And right now, that's IPv6. We're not going to do that on v4. We're not going to go through firewalls, through NAT, through encryption gateways, and actually have people communicate. Yes, if you're physically close to someone, you can do near field and exchange. So what? The real promise here is not physical replacement of cash. It's being able to have someone, say in this country, say where they were born and code or write or trade with someone in New York and be paid instantly. That's the real promise of electronic cash. So someone can be a writer and not have to move. Someone can be a coder and not have to move. These things allow you to actually trade without leaving where you were born. You can stay in a small community and bring money back to where you were. That changes a lot of things. When you have this idea that everyone has a speculating gambling asset, that's not interesting. There are lots of speculative gambling assets. But when you can take transaction fees down to what we're aiming for, 1,000% or less, then everything changes.
So Bitcoin should be just considered a simple system. You don't need multiple nodes, multiple ledgers doing multiple blockchains. That idea is daft. How many of you actually think that having multiple sets of books in a company like, say, Bernie Madoff's was a good idea? Bernie Madoff had immutable ledgers. Every corporation in America runs under worm processes since Sarbanes-Oxley. That means write once, read many. Every one of them. Immutability in ledgers is not new. It's a legal requirement, and 5+ years in prison for any CEO in America whose company can be shown to have a record that can change. There's a way around it. You run 2 or 3, or like Bernie Madoff, 7 copies of the books. So if you have 7 blockchains, pick the one that you want to show at any time. Yes, we've got an immutable record. I'll show the SEC. Yes, we've got an immutable record. I'll show the IRS. Yes, I'll show my investors, and they'll all be different. So, peer-to-peer is about privacy of exchange, not about anything else. So when we're doing this, we can still link identity, but we want to link identity in a different way than people did with PGP, etc., by having keys that can actually link back to an original identity, but still be traceable. If the police want to trace a drug deal, they have to do it step by step. Not the NSA or GCHQ methodology of just scanning the entire internet, but old-fashioned policing, where I go up to this guy and he gives over that guy, and slowly we build up what's happened. Not we trawl the entire world to find something wrong, but we actually do policing, detective work, the stuff that used to happen when I was a kid, that now the computer can do it. No. So we want a private accounting system that allows for those exchanges to be registered. So we can still do this even if they're offline. Everyone's going, oh, but we need to send it to the network. How will they get it otherwise? I can email you a transaction. I could send it to the network and email you a transaction. I could post it on a web page. I could put it on an FTP server. If you're old enough, you could put it on UUCP. I don't really care. There are many ways of getting things to people. For instance, if you're offline, you still get Facebook messages or TikTok messages or any of these other things. You don't need to be there watching to get them. So we can build all sorts of fun systems doing this. And with SPV, which is mentioned in my white paper, we don't need to have everything sent to everyone. That's the whole point why you don't need to be nodes. If I can point you to the hash header and then a Merkle proof, a binary tree path, then you can verify your transaction, not everyone's. There's a reason for this. You shouldn't care about everyone's. If we're scaling this to billions of transactions every block, why do you want to check all of those? Why do you want to run everything? So again, we're now taking a system that we want to build anything on. I'm old, so yes, it's based on Forth. I grew up in things like C++, C, C Sharp, that was later, but and Forth. So these different areas that people like to think about in coding, well, these are actually still able to be used. We're still able to build a lot of things. Just because it's Forth doesn't mean you can't do things. Just like assembly language, you can do a lot of things. If we learned how to use it, we'd be able to do even more, but we're not teaching that anymore. So anyway, private and direct, this is important. It's equivalent to EDI. EDI is electronic data interchange. There's no such thing as a smart contract. You can do EDI. EDI has been around since the early 80s. It allows you to have electronic communication and update, but you have to agree as a contract first that this will be your methodology. You have to have an agreement about how exchanges work and what the terms are to get out of them. If you don't, then you don't actually have a contract, because machines don't contract, ever. Part of contract is meeting of the minds. Machines don't have minds. I know everyone loves to say AI, artificial, actual ignorance in my opinion. I've studied statistics. It's not smart. Don't take all the things where they say about pictures that machines have done. Now, if I randomly throw paint at a wall, and I do that 100 billion times, one of those might actually be good. And the way that we find that with AI is we get a human to walk in and take out all but one of them and go, that one's okay. That's not a machine. That's not machine intelligence. That's still human intelligence. When we get a human to pick out of the 100 billion things and even put it on a whole lot of sites so that we can crowdsource it, human intelligence. Sorry. Machine does a whole lot of automated work. Humans have the intelligence. So we want to get this so that we can do things like secure transactions. With CGA++, we can integrate that within a combination of IPv6, Bitcoin, etc. That now allows us to go right down to packet level exchanges. So if we integrate a combination of this, payment channels that I've talked about way back in the past, and we now integrate IPv6 and Bitcoin, this allows us to take around 4.3 billion transactions per payment, which effectively, a payment for 1,000th of a cent, you can exchange 4.3 billion jumbo packets, and a jumbo packet can be 4 gigabytes. So Bitcoin scales a long way. If you think about 4.3 billion exchanges for 1,000th of a cent at 4 gig each, that's a lot of data exchange for a very little amount of money. So when we're talking about how much this scales, the world of 100 billion machines, all this stuff, doable right now. We can set up all these exchanges right now. And we don't need to record everything on the internet. We don't need to have every transaction finalized. For instance, maybe you only want a hash of all the negotiations and you store everything on your own machine offline. Why? Because do you want all your communications to be public? All these things about people going, oh, I can put all my pictures on the blockchain. That's why we have things like overlay networks. So we can create domain name structures sitting on top of this, allowing us to now connect. Some examples out there with things like Paymail have been done already. This now allows you to create and integrate keys and hierarchies into the version 6 of DNS, IPv6, etc. So now mobile IP can be developed, and you can have something where not only do you pay an ISP monthly, but you can actually pay per packet. And that could be globally roamed so that you change to different providers, you negotiate instantly, rather than have exchanges for gambling on. Your exchange could be, which do I get a better internet service on? And you could tokenize each of that at fractions of a cent. Now, if you're doing 4 billion transactions exchanged on a single payment, and your fees are 1,000th of a cent, then paying even 1 cent at a time for that. So each day you pay 1 cent for a number of transactions to a provider, whether it's 5G, whether it's IPv6 direct data communications, etc. We now have new models for actually building how we fund websites, how we fund access, how we fund data. We have sites that now can build and monetize what they're doing without going to the advertising model, like Google, Facebook, etc. The advertising model is the most insidious thing we have on the internet. 80% of all advertising is controlled by a few companies, very small part of the world in California, which allows them to have all their wacky, stupid, bloody ideas, which is the only way to put it. They're daft, freaking, uneducated ideas on the rest of us, and they are. Training is not education. Education is about wisdom and culture and knowledge. So I'll basically say it. I don't know anyone in California. I'm sorry if there is someone in California who's actually educated. Sorry, Jimmy. That's why you left. Sure, no. That's the real reason. Anyway, so we can now do it so that you can actually go out there and trade on all levels cheaply. IoT as well. Each of these machines, smart cities, etc. We can start recording all of the differences in how people travel. We can have differences in what they go through in different roads. We can have differences in if you need to go faster, you can pay more. If you can have an emergency, you can be routed into different lanes. All sorts of fun things. And we can build all this now too. Not with congestion, not with high fees. The ability to not care. By actually doing direct communication between these machines, IoT, then what we end up with is now the ability to have very simple machines that watch and translate and just look for a signed transaction. That enables very low network latency, direct communication, not going through servers, not having to have this traditional model where IoT machine looks at a server in the cloud, looks at something else. No, direct communications. These things can actually talk. So traffic lights could update each other so that, well, maybe they're not actually one after the other causing problems in traffic, that they open up all at the same time and they communicate. So we can form communication interchanges. We can build systems that actually exchange information between each other. We can have multi-level control systems. Now, part of all this is creating an architecture where the different levels communicate. So we can form topographies of machines. And by forming topographies of machines, we can start looking at which devices at which time talk. So our end devices and our servants, our slaves, etc., can all communicate the required information correctly, and only the required information. So not everything gets stored in a blockchain, only the relevant information need be stored. In multi-layered networks, this allows us to have saving information on one, but having a hash index, and there's no encryption in Bitcoin, but there is an indexing function. When people talk about a cryptographic hash, it's not an encryption function. It is a hash function or an index that is able to be used in a cryptographic algorithm because it's that effective. One of the problems with hashes, and there are simple hashes, anyone doing Python coding or anything like this will see some of the simple hash type functions you could do, where there are collisions all the time. A cryptographic hash has very low rates of collisions. That's really what it's about. So these machines now enable not only communication, but payment, monetization, and recording of everything with a perfect record. So there's no cheating. If you record something now, you can't go back and change it in 5 years. The record is recorded permanently. There's no altering the past. And this has been the problem with things like PKI. So it's more secure. Why? Because there's a record of when it occurred. There is a record of all the ability to trace the logs and prove that they existed at the point in time, which only works if we have one ledger. If we have 20 ledgers and we choose the one we want to show, then we do the equivalent of front runners in share schemes where they do multiple sort of issues. I send out to everyone my share predictions in this class, and half of you on the first thing, it'll go up, and I predict it'll go up, and the other half I predict it'll go down, and if it goes up, half of you go, wow, he predicted, and then I do it again, and a quarter of you go, wow, he's predicted twice. And I go through this until I get a few of you, like maybe a 16th of the class here, who now go, wow, this guy can predict anything. I'll give him money. And then I fail. But I keep your money. So that's how this works. So when we're doing this, we can use Bitcoin as a base layer, integrating and indexing all of the communications. That allows us to actually form multi-level networks where we have an index of what's happening, a record. But it doesn't mean we store everything. It allows us to prune. So we only want partial networks of what we want to communicate with. So we prune everything else when we basically display. This now creates a base layer of different hierarchical network components, allowing us to directly communicate, which is peer-to-peer. Alice Bob, not I find a node and then I search this node to try and find my transaction that might be there, if I'm lucky. Yeah, not how it works. We can then create contracts. We can create updates. We can automate systems, allowing all of this technology to create a secure methodology for communication, a way of, well, having trust built in, and equally doing things like making sure that software is secure. So PKI problems, DigiNotar, for instance, was a major certification authority, got hacked. The problem with that is when the keys are hacked, you don't know when they were hacked. If you don't have a record of what changes were there, you don't know which contracts were in the past invalid. So when DigiNotar, Dutch CA, was hacked, there were over 8 years worth of contracts had to be re-signed because no one could tell which ones are valid and which ones weren't. That doesn't work. But if we have blockchain technology, you can go, the hack happened in the last 6 months, then 8 years ago, that contract's still valid. That simple. So we can create systems where we actually now sign software, and we know when updates occur, when compromises occur, and who might have done them. And in all of this, we can even do things like, not NFTs that we're seeing with boring apes, but proper things. We could have real digital artwork. Now, I study many areas, and one of those actually happens to be art history, funny enough. And there are digital artworks. They're not on NFTs. There's a reason, because people actually have scarcity on real art. There is real art that sells because it is real art. It's displayed in the Louvre. People have actual displays of digital art. But if you put those on YouTube, you don't really own them anymore. If you have an IPFS link, you don't own it anymore. And saying, oh, I've got a token, so what? So we can do this properly. And when we do it properly, we build a system that people actually maintain value and control of their own lives. So imagine someone here, Northern Africa, Africa generally, being able to become an artist and sell something and display it in New York and earn money while staying here, not having to slum it in Brooklyn or something like that while they're trying to make it, but anywhere in the world, staying home, bringing money back to their own community, earning. Thank you.